Yes, hello students, welcome back to our channel. So in our previous video we have talked about the ionization enthalpy or ionization energy, that is the energy which is required to remove the outermost electron from a neutral gaseous atom. We call it as ionization enthalpy, and also we have discussed regarding the variation of ionization enthalpy along the period and down the group also. So in this video now let us talk about the next physical property, that is electron gain enthalpy. So this electron gain enthalpy is indicated by delta E into H. Yeah. So we know that as the name suggests, what do you mean by ionization enthalpy? Let me repeat it. Ionization enthalpy, it is the energy required to remove the outermost electron. That means whenever the electron is removed from the outermost or the valence shell, that has to be accommodated for another element, right? So at that time one is losing electron, means that electron which is lost has to be gained by another atom, right? So that the enthalpy change when an extra electron is added is known as electron gain enthalpy. Let us read the standard definition for this. Electron gain enthalpy is the enthalpy change when an electron is added to, the enthalpy change when an electron is added to the neutral gaseous atom. Neutral gaseous atom, we denote it as X. Okay, the electron we denote it as E minus. Okay, so it is added to a neutral gaseous atom. The enthalpy change when an electron is added to a neutral gaseous atom to change it into a negative ion. Negative ion is called this electron gain enthalpy. Clear? So this is the simple definition. So if we have understood ionization enthalpy, that is regarding the removing of electrons. So when an electron is removed, it has to be taken place, it has to be accommodated in one more atom. Okay, so that change in enthalpy or that change in energy when an electron is added to the neutral gaseous atom, that is neutral gaseous atom, so that change in enthalpy is known as electron gain enthalpy. Let us check out the standard equation for this. We have the neutral gaseous atom, that is X. Okay. So we have this neutral gaseous atom, okay, and when an electron is added to it, we know that electrons are negatively charged particles. So when an electron, that is negatively charged particle, is added to the neutral gaseous atom, it acquires a negative charge. So the enthalpy change in this process we call it as electron gain enthalpy. That means the enthalpy change which has taken place when an electron is added to a neutral gaseous atom to make it negatively charged ion. We know that when an electron is added, the neutral atom is converted into negatively charged ion. When an electron is removed, the neutral atom is changed into positively charged ion. Yeah, because as electrons are negatively charged. So this we call it as electron gain enthalpy. This is the neutral gaseous atom. We have electron over here, and this is the negatively charged ion. Negatively charged ion. Okay, so this is the concept of electron gain enthalpy. Now let us take more information regarding this. Okay, so this electron gain enthalpy, that means addition of electron to neutral gaseous atom, is of two processes. One is it is an endothermic process sometimes, and sometimes it is exothermic process. Okay. So this process, sometimes when an electron is added up to a neutral gaseous atom, heat energy is liberated out, whereas sometimes we need to, that is this one. So sometimes we have to put some external heat energy in order to make this electron to be added up to the neutral gaseous atom. Okay, so now let us understand these two processes. Endothermic. Therma means we know that it is related to heat and temperature. Endo means it is inside. Okay, endo means it is inside. So when an electron is added to, noble gases, that is 18th group elements, when an electron is added to noble gases, then the energy is required. That means there will be positive electron gain enthalpy. That means you know that why in case of noble gases it is positive. It is because noble gases have a stable octet configuration, that is NS2 NP6 configuration. That means their shells are completely filled. The maximum number of electrons that can be accommodated in the s orbital is 2, and in case of p orbital it is 6. They have already got the enough or completely filled shells. So whenever if you want to add some extra electron, so there will be positive electron gain enthalpy. Why? It is because as they are having already complete octet configuration, when you have to add an extra electron, their principal quantum number changes. Principal quantum number changes, you know that, okay? And there will be addition of new shells, okay? So because of that reason, there will be positive electron gain enthalpy. And in the second case, we have exothermic process. Exothermic process. In this case, when an electron is added to, 17th group elements, like we know that they are halogens. There will be negative electron gain enthalpy. That means the heat is getting liberated out. This is the concept. Why in case of 17th group elements heat is getting liberated out, and that is we have the negative electron gain enthalpy, because in 17th group elements we know that their electronic configuration is NS2 NV5. That means they require one electron to fulfill the stable octet configuration. They will be worrying for that one electron. So as soon as you get one electron from this 17th group elements, they acquire more happily. So for this reason, there will be negative electron gain enthalpy. So these are the two processes of electron gain enthalpy. One is will be exothermic process and endothermic process. Now let us look at the variations of these two. So in most of the cases, electron gain enthalpy will be negative itself. Only in case of noble gases it is positive. We know that I have discussed because of its stable octet configuration. Now let's check out the variation of electron gain enthalpy. Yeah. So along a period, okay, So as we move along a period from left side to right side, you know that atomic number increases. So the electron gain enthalpy will become more negative. There will be, as we move from left to right in the periodic table, there will be more negative electron gain enthalpy. There will be more negative electron gain enthalpy except these noble gases. Okay, and down the group, what happens? Down the group, that means as we move from top to bottom, there will be less negative electron gain enthalpy. As we move from top to bottom in the periodic table, there will be less negative electron gain enthalpy. Okay, so this is the concept of electron gain enthalpy. One more important physical property. Let us continue regarding electronegativity in the upcoming classes. Thank you.